Hello, everyone. On behalf of the Special Program on Immunization of the Pan American Health Organization, we welcome you to the video tutorial for the installation and use of the polio risk analysis tool. In this first module, we will discuss how to download the risk analysis tool, explore the files and folders contained in it, and prepare the maps of our country to produce geocodes that will allow us to collect data at the administrative level too. The data presented in this video are completely fictitious and have been created for teaching purposes only. Any similarity to real data, persons, or events is purely coincidental and should not be interpreted as an accurate representation of reality. This content is designed to illustrate concepts and promote learning through purpose-built examples. This video focuses on 3 points: how to download the aforementioned tool, how to prepare the necessary maps for it, and how to fill in the information for the tool in order to calculate risk analysis. And we will explore visualization. This video assumes that you already have R and RStudio installed on your computers. If that's not the case, please follow the steps indicated in the link provided in the description of this video. As a first point, where can we find the tool? This tool is hosted on github.com, a free repository for code and programs. The specific link is shown on the screen, and it has also been provided to you prior to this video. In this video, we assume that you have never used GitHub before. Therefore, the easiest way to download the tool is to click on this button in green, marked code, and then click on download zip. This will download a zip file, so it will be important to carefully note the directory where it was saved. Once the directory is located, we will have to unzip the file. This is because the file is downloaded compressed in zip format. To do this, right-click on the zip file and then click on Extract All. The next dialog will ask us where you want to decompress the file, and you can choose the same directory where you saved the original zip file. Having done this, we will work from now on with the unzipped directory. In the directory, whose name is polio risk main, we find a series of files and folders. At this stage, what we're mainly interested in is the file poliorisk.rproj, which will allow us to open the tool in the RStudio program. In addition, inside the source folder, SRC, we will find the qa.r file and the run.r file, and we will also find the folder shapefile.rep, which contains the program geodata to shapefile R, which will allow us to generate the shapefiles that describe the geography of our country. Now, returning to the source directory, we also find the data directory, where we will place 2 things later on. First, the flag of our country in a PNG format with the name country flag PNG. And second, the data that feeds the tool inside the file country data XLSX. We'll come back to this later on in the tutorial. Now, if we go back to the main directory folder, we also see the template folder. Inside this folder, there are 4 additional folders, 1 for each official language of the organization. Each folder contains a file called country_data.xlsx. And these are the templates that we will use to fill in the information that feeds the tool. With this brief explanation of the files inside the tool, we can now move on to open it with RStudio. And to do this, we go to the root folder and click on the file poliorisk.rproj. This will open the tool RStudio automatically, and we will able to use it to move on. Inside the RStudio file browser, which is in the lower right corner, we will see a file called install.r. Open that, and we see that it only contains one line of code. This program is in charge of installing all the necessary packages for the tool to run correctly. And to run it, we click on the source button. After this, it will start downloading a series of packages, which may take a few minutes depending on the speed of your internet connection. When they finish downloading, a message will appear asking if you want to install the packages. And you must respond by typing the letter Y and then pressing enter. This will install all the downloaded packages, which may also take some time, depending on the speed of your computer. When it finishes, it will tell you how many packages were installed. Once all these packages are installed, the first step to complete this document is to collect the geocodes that correspond to each of the departments, administrative level 1, and municipalities, administrative level 2 in our country. This is because the tool generates in the final phase a series of maps that must be related to the data you will provide in this document. For example, for Guatemala, the Department of Guatemala has the geocode 01, and the municipality of Guatemala City has the geocode 0101. These codes will be the ones we will use to relate the polio data to the maps. Let's use an example of Guatemala. To begin, we must have the file that defines the map of our country. So in the case of Guatemala, we have the file called guatemala.json. Now, depending on the country, the format of this file can be either shapefile, GeoJSON, TopoJSON, or others. So once the file is ready, we will move on to the next website called mapshaper.org. Once there, we can take the file that defines the maps of our country, guatemala.json, and drag it to the bottom section of the page, to the section that says Quick Import. This will open the file and allow us to visualize the map. You will see that, in this case, you will see the map of Guatemala with its divisions up to administrative level 2 or municipalities. With the map open in MapShaper, we will now go to the tools folder, the source folder specifically, and then the shapefile prep folder. There we open shapefile settings.xlsx. This document is used to give the tool the name of the variables that appear in our map, which these variables change from country to country, and that's why we have to standardize them. In the file admin1, in the row admin1 ID, we must place the name of the variable of our country. Now, if we go back to MapShaper, we can explore those names. We click on the arrow on the right side of the screen and then on Inspect Features. This will allow us to place the cursor over each municipality in the country and see the information it contains. For instance, if you put the cursor over the large municipality in the upper left corner of Guatemala, we will see that it contains 4 variables: admin1G, GeoID, admin2, and admin1. Since when filling in this tool, you will know the geographical distribution of your country, it'll be easy for you to identify which variables refer to the name and geocode of administrative level 1 and which other variables refer to administrative level number 2. For instance, In the case of Guatemala, we know that admin 1G is the geocode for administrative level 1, and admin 1 is the name of that administrative level. Similarly, GeoID is the geocode of administrative level 2, and admin 2 is the name of that administrative level. So once you have identified this, we move on to Excel. We will copy each of these names and place them in the respective field. We copy the name of the geocode of administrative level 1, admin 1G, and paste it in the row that indicates admin 1 ID. Then we copy the name of administrative level 1, admin 1, and paste it in the row admin 1 name. Then we copy the name of administrative level 2, GeoID, and paste it in the row admin 2 ID. And finally, we copy the name of administrative level 2, admin 2, and paste it into the row admin 2 name or number. After this, there are 3 rows left to check in Excel. The first row with the file type asks us if the file we are using is of the type JSON or SHP. In this case, we know that the file is a JSON type. Likewise, it asks us the name of the file. Since it's called Guatemala.json, we place Guatemala in that row. And finally, we have the row called geometry. That row is always the same. It retains the name geometry. We can give you another example with another country. Let's use a map of Paraguay. In this case, we have the file name Paraguay Distritos 2022 simplified.json. If we were to fill the file shapefile settings with the data for Paraguay, we would start as follows. First, the file is of the JSON type. So again, we select JSON in the first row. Then we place the file name, which, as we saw, is Paraguay Districts 2022 Simplified. Having done this, we now upload this file to mapshaper.org to see how the variables of each administrative level are called. And remember that to load the file, you simply drag it to the quick import section of MapShaper. If we click on the right side and again click on Inspect Features, we can visualize each municipality and see that this file contains different information. First of all, we see that now the geocode for administrative level 1 is called DPTO. The name of that administrative level is called DPTO desk, DESC. And the geocode for the next administrative level, level 2, is called code 2. And finally, the name of the second administrative level is desk underscore. With this identified, we now move on to filling in Excel. In admin 1 ID, we will put DPTO. In admin 1 name, we will place DPTO desk, DESC. In admin 2 ID, we will place code underscore 2. And in admin 2 name, we will place dist underscore DESC underscore. So with these 2 examples ready, we can now go back to the Guatemala case. Once we have completed the file shapefile settings.xlsx, we must make sure to place in the same folder the map of our country. That is, we must place in this folder the file guatemala.json that we used previously. With this ready, we return to RStudio and we go back to the shapefile prep directory. Here, we will open the file geodata to shapefile.r. As you will see, it has several lines of code, but you should not modify anything here. If all the files have been placed in the correct directory and all the variable names have been identified correctly, we just need to run the program by clicking on source. The execution may take a while to complete. When you will have created the file geocodes names.xlsx within the file shapefile.prep. If we open the file, we will see 4 columns, and each one contains the geocode and the name of each of the administrative levels.
We need this information in order to complete the country data Excel files. Therefore, we copy the data in the 4 columns and paste it on the population area which is in our data file. You will see that the columns are in the same order, so we can simply copy and paste them. This gives us a series of rows with geocodes and the names of each of our admin levels. We will repeat this for all the Excel sheets. So we'll repeat the copy and paste process for population immunity, surveillance, determinants, and EPV outbreaks. Once we have done this for each sheet, we will have a template that is ready for inputting information. This concludes section 1 of this tutorial. In section 2, we will explore the Excel file we saw at the end of the previous module, and we'll fill in information about each country, and this will be the basis for the risk analysis and for all the products that are going to be produced by the tool. In addition, we will have some quality control steps to verify the quality of data we have entered into the Excel. At the end of this video, we'll be ready to generate the results dashboard produced by this tool. Next, we will open the template we filled out in the previous module. We will see that it has a number of sheets. The first tab is General, and it has basic information about your country. You can fill in each field with the information for your country. In the first row, we'll have the country name, in this case, Guatemala. After that, we'll have the year during which the risk assessment is being carried out. So in this case, it's 2024, this year. We will select the language in which we're going to carry out the evaluation, which in this case will be Spanish. So we select SPA. Then we include the number of municipalities in our country. In other words, the total number of units in administrative level 2 for Guatemala. For the second sheet, it's population area. Under this tab, we will input information related to the country's population for different age ranges for each municipality or administrative level 2 in the country. On sheet 3, you will enter all data related to the population immunity. In other words, variables related to vaccination. On sheet 4, we'll collect information related to VFA surveillance. It's important to note that on this sheet, there are some variables for which you should only input data if the municipality has more than 1,000 individuals under 15, or if it has a smaller population but reported cases for the year that it's being evaluated. Likewise, there's another variable that only applies to municipalities having a population under 15, less than 100,000, and did not report PFA cases during the year of the evaluation. For sheet 5, there will be variables and health determinants. And finally, sheet 6 will collect information regarding cases and outbreaks of the disease, preventable or vaccine preventable cases of the disease. If you'd like to know more about the variables on any of these sheets, you can turn to the last sheet, which is entitled Glossary. There you will find a definition of each variable in the document. Now, your job for each sheet and each row on the Excel, you will have to fill out the information. Let's assume that the data is already in. We use a country data.xlsx as a sample with information for Guatemala that is not real. In order for the tool to read this file, we need to save it under the data folder, which is in the source project folder. We move the file to this directory, and once we've done that, we can go back to RStudio. We're almost ready to generate the final dashboard, but first we need to verify the quality of our data to detect any errors on the country data XLSX sheet. We open RStudio and go to the main directory. There we open file qa.r. This file has many lines of code that we're not going to change. We will simply run it by pressing on the source button. In some versions, you may see Run App. This program will analyze the quality of our data and will produce a report which will open automatically in a new window. Once we have completed this analysis, we'll see a window titled Incorrect QA and a red X. This means that there are errors in our file and that we need to go back and review it before we run the final version. To find the errors, we click on the Download Report button, which will open a dialog box asking us where we want to save the report. We would then save a folder that is easy to remember and then save it. If we go to the folder where we save the report and open it with Word, we'll find a document entitled Data Quality Review. This document has 7 sections. The first section reviews the quality of our shape files. In other words, the files we use to define our country map. In this case, there are no errors, and the map is correct. Then we go on to the next section entitled General Data that relates to the first Excel sheet we filled out. The program did not find any errors in this section either. All the remaining sections correspond to one of the Excel sheets we filled out. The next one is population data, which corresponds to the sheet entitled Population Area. The first table, we see that there are no errors in this section. Look at the next section, which is entitled Immunization, Population Immunization, Immunity. We see that it corresponds to the third Excel sheet. There's 3 data items missing there, whether the population under 15 is under 100,000, if there were PFA cases in 2022, and to see the data, we can refer to the table that is slightly below. We can see that in rows 77, 79, and 93, there are 3 data items missing. If we open the file in Excel, and we go to these rows, we will see that they were not filled out. And this is something we need to correct. Let's take another example. For the same section, there are 2 data items missing in the field polio campaign with a coverage greater than 95%. If we go to the corresponding table, we will see that there's a table with 10 rows. 2 of those rows say NA. In other words, the 2 missing data items, and the other 8 rows say yes or no in lowercase letters. If we go to the Excel, we will find rows 249 and 315 that is where we find the missing data. And we go to another row like 116, we will see that it says yes or C in lowercase letter. It should have been written with uppercase S and lowercase I, as in the other sections. If we correct these mistakes and we run QA.R again, we will see that they no longer appear in the document. The rest of the QA works in a similar manner. There will be an initial summary table showing the columns where data is missing, and there will be other specific summary tables for each column indicating the file where the error or missing data item has been identified. So this is an iterative process. You will need to run the QAR program to find mistakes, correct them in the Excel, ensuring that you are saving the file with the changes each time, close it, and then run the same QA.R program again. And each time the report will be cleaned up. Once you get to a point where there are no mistakes, or if there are mistakes, it's because optional information was not provided according to the glossary, you will be able to move on to the next and last step, running the tool to produce the final report. This ends section 2 of this tutorial. In the third section, we will run the final report using the tool and look at the different visualization modes and tables. We will go to RStudio and run the file run.r in the source folder. We will open it and click on the Run App button. The process may take some time, given that the program does not only generate the report you'll see at the end, but it also produces a series of documents in Word and HTML format, which contain all the material shown in the report.
Dependiendo de la cantidad de información que se está procesando, de la cantidad.
Finally, depending on the various filters being used, this process can last more or less time. You can see on the screen an indicator of how far it is being installed. At the end, you will see a board, a local final product that appears on your screen. If we move the cursor on the screen, you'll see that there are several tabs on the left side of the screen to which we can navigate. And it also has some filters that we can select on the same side. The first filter allows us to change the level to administrative level 1 or to the national level. The second filter allows us to select whether we are seeing municipalities with less than 100,000 inhabitants of under the age of 15 or more than 100,000 inhabitants under the age of 15. And the next filter allows us to specify by risk category. In this case, we can see the municipalities that have a high risk category, high, medium high, or low. Each time we interact with one of these filters, the graphs and the tables and the screen indicators change or are modified. Additionally, we can also navigate to the various tabs to see the results based on specific risk components. First, we'll go to the tab called Population Immunity. And in this one, we have several useful visualizations. In the first section, we can see the total number of risk points. We also can see the coverage with polio 3. We can see coverage with IPV2 and the polio campaign with a coverage greater than or equal to 95%. In the chart on the right-hand side, we can see a pie chart that shows us the distribution by municipality of risks for the departments chosen or for the entire country. Additionally, we have a tab where we have a chart with data that is interactive and shows us the level of risk that we have in each one of the municipalities. These charts can be downloaded separately using the buttons at the top of the screen. If we now go to the tab on the left-hand side, surveillance indicators, you see the structure is fairly similar, but the risk categories change. In this case, it is specific to the risk category covering surveillance indicators. We have total risk points, notifying units, AFP rates, timely notification, timely research, at appropriate samples, case follows through, and active searches that have been completed. We also have a chart and a pie chart and a graph that we can download independently. Now, if we scroll down, we see that we also have a chart that shows you the risk points by municipality for this category. If you recall, this is fairly similar to the table you filled in countrydata.xlsl, but has additional variables that have been calculated to take into account the risk indicator. We also can now look at the health determinants tab and outbreaks and navigate through it. This is the interactive part of our report, but we also have another additional function which allows us to download a Word report that shows the entire content of this report, or an HTML format report that also includes all the information. We will now show you the Word report. When you click on Word report, you see a screen open where you have to choose where you would like to download this report to. In this case, we are saving it in the download folder. If we open the report, you will see that it has a brief description of what has been shown, and it has all the graphs, maps, and visualizations that we saw in the various sections of the report. With this, we now conclude this tutorial for how to use the polio risk analysis tool. We hope it will be useful to you, and you can get in touch with PAHO and the immunization team to answer any questions you may have about the use of this tool.